Howdy folks, welcome to lesson 5 of the CompTIA Network Plus course. As you can see, today's lesson is binary conversion. Now to be honest with you guys, we're not just going to be doing binary conversion, we're also going to be converting backwards. So what I mean by that is we're going to be converting from decimal back to binary. So we'll go from binary to decimal, so that'll be ones and zeros to your normal decimal numbers, which is from 0 all the way to 9. And then we'll go backwards. We can actually go both ways in this specific video. Alright, so before we jump into this lesson, guys, if you haven't done it already, give the video a like, show the channel some love. I do put a lot of effort into these videos. And if you'd like to know when lesson 6 of this course comes out, or just in general my other content, maybe consider subscribing. Alright, folks, let's go learn something. Alright, cool. Now that we've done the cool fun intro, a bit of general information about the IP version 4 addresses before we get things started. So first things first, I'm going to give you guys a random IP address. There we go. So it's a completely random IP address. Alright, so now that we've got an IP address in front of us, the first thing I want to mention to you guys, and I'm sure some of you guys might notice already, is an IP address version 4 or a version 4 IP address consists of 4 octets. If you're not sure what the octets is, that's basically 4 different numbers there. So you'll see they're separated by little dots there in the middle. So there's 4 little octets here in a standard IP address. Alright, now what else you need to know is each of these 4 octets, folks, consists of 8 bits. Now, a lot of you guys probably don't know what I mean by bits. So if you don't know what a bit is, guys, that's either a 1 or a 0. Computers tend to work with 1s and 0s. So in other words, there's 8 1s and 0s in each of these 4 octets that we've got there. Now, since there is 4 octets and since there's 8 bits in each of these octets, how many bits does an IP version 4 address consist of in total? Well, guys, that is 8 bits times 4, so there are 52 bits in total in an IP version 4 address. So that is 52 1s and 0s. So now that we have a little bit of a background as to what an IP address actually consists of, the octets and the bits and all of that, now we can proceed to actually converting this IP address in front of us to binary, in other words, 1s and 0s. And once we've done that, I'll go and do it backwards for you guys, just so you guys can get an idea as to how we can go about this. Now, before we jump into converting, guys, something you need to be aware of. There's actually multiple ways you can go and convert from binary to decimal and vice versa. So after you've watched this video, I do encourage you to go and check online, maybe on YouTube or wherever you guys want to go and see if you cannot find other methods as well. There's many ways to work something out. For those of you that had math in school, you would know there's always more than one way to get to the answer. And what I'm about to show you guys in this video is simply one of many, many methods. The method I'm going to use is going to be a table. Unfortunately, the table I'm going to use, I cannot take credit for it because I did not design the table. I wish I could because it's a flippin' awesome table. But you will find this table mentioned in many, many manuals. Now, the exact same table will be used, but they don't always use the exact same method with the table. I'm going to show you guys the easiest method I've seen with regards to converting binary to decimal and vice versa, because not everybody likes maths and, well, not everybody's very good with math. So to help the folks out that want to learn this, but you might not be very good at math, this should be the method for you. But I still encourage you to go and look up other methods. Alright, so let's go and do the table. I'm going to first give you guys a blank page, and we're going to use the same IP address. I'm going to put it at the top right hand side. There we go. And there is 8 numbers. So I'm going to put 8 numbers here on the screen. I'm going to draw a bit of a table for you guys. There we go. So if you count the numbers from left to right, you'll see there's actually 8 digits. We've got 128, that's the first one. 64 is the second, 32 is the third, and if you go check, you'll see there's actually 8 different numbers. How many bits is there in an octet? 8 bits. So what we're going to be doing, guys, is if you look at the IP address at the top right hand side, we're going to convert that to binary 1 octet at a time. Unfortunately, you cannot do the whole IP address in one go. You're going to have to do it 4 times. So we're going to start at the octet on the left, being the 192, And we're going to convert that to binary. And once we're completely done with that, then we'll move on to 168. And then we'll move on to the 15. And then we'll move on to the 7, of course, the last one. So we're going to have to do it 4 times. And the same actually goes if you want to go backwards. If you want to go and convert from binary to decimal, it's also going to be 4 times. So what I'm going to start you guys off with, so we've got the table now in front of us. At the bottom left, there we go. I'm going to add the first number. So that's our number, our magic number. It's 192. We need to convert that to binary. Now starting on the left of this table with the 128. That 128, guys, is it smaller or equal to 192? If it is, we're going to make a 1 underneath it. So every time we're going to compare that number at the bottom left, the 192 in this instance, we're going to compare that to the number in the table. The first number in this case is 128. And we're going to check if the number in the table is smaller or equal. If it is, we're going to put a 1 underneath it. If it's not, we're going to put a 0. All right, so I'm going to explain this as we go along. So the first one, 128, is indeed smaller than 192. So we're going to put a 1 underneath the 128. Should it be a 1, then you're going to take the number in the table, which in this case is 128, and you're going to subtract it from that pink number that I've got at the bottom. So I'm going to subtract 128 from 192, and that gives me 64. So 64, guys, is my new number. Now, going back to the table, looking at the second number on the table, which is coincidentally also 64. Is that 64 on the table smaller or equal to my new number at the bottom left, which is also 64? Well, guys, it's equal. And if it's smaller or equal, we put a 1 there. And if there's a 1 underneath it, there we go. There's a 1 underneath the 64 now. Then you take the number in the table and you subtract it from the number at the bottom. But if we were to have gotten a 0, let's say for a moment the number in the table was bigger, then you would have made a 0 and nothing changes. That number at the bottom left, which is currently 64, it would not have changed, and you just move on to the next number on the table. But every time you get a 1, when you take that number on the table, which in this case is 64, and you subtract it from the number at the bottom, which is also 64 in this case, and well, what's left? 0. As soon as you hit 0 there on the bottom left, then you know automatically everything else on this table is going to be a 0, because every number, even the last one on the table being number 1, even that is going to be bigger. Every time the number is bigger, you make a 0. So, but just to, do it slowly, let's do it anyway. So looking at the number 32 there, is that smaller or bigger than my new number? My new number is obviously 0 there at the bottom left. 32 is obviously bigger. So we're going to put a 0 underneath 32 and nothing changes. Moving to the next one, 16. Is that smaller or equal to the 1 at the bottom left? It's bigger. So if it's bigger, nothing changes. 8, same story. It's bigger, nothing changes. We're going to put a 0 there. 4, that's going to be a 0 because that's bigger than 0. So 4 is obviously bigger than 0. So we're going to put a 0 underneath 4. Looking at the second last number, then number 2, that's bigger than 0. So we're going to put a 0 underneath it. And then the last one, folks, even number 1 is bigger than 0. So we're going to put a 0 underneath it. So there we go. We've got 8 1s and 0s. So in this case, it happens to be 2 1s followed by 6 zeros. We have just converted the first octet successfully, which is 192, to its binary form. So just to help you guys out, I'm going to put that number here at the bottom left. There we go. As you can see, there are 2 1s followed by 6 zeros. Right, moving on to the next number. So I'm going to clear the table, obviously, so we can do the next number. So our next number, guys, is 168. So just like when we started with 192, I'm going to put 168 at the bottom left there. There we go. It's in pink. Starting once again with the first number on the table, being 128. Is 128 smaller or equal than 168? Yes, it's smaller. What happens if it's smaller or equal? We put a 1. So we're going to put a 1 underneath the 128. And I'm using different colors this time, just to distinguish. So I'm going to put a 1 there. Every time we get a 1, what happens? We subtract that number, which is 128, from the 168. So I'm going to subtract 128 from 168. My new number now is 40. Now, comparing 40 to the next number on the table, being 64. Is 64 smaller or equal than 40? No, it's not. It's bigger. If it's bigger, we put a 0. So nothing changes. The number remains 40 at the bottom left. Moving on to the next number on the table. 32. Is 32 smaller or equal? Yes, it is. So we're going to subtract 32. So we're going to put a 1 obviously underneath 32 there. And we're going to subtract 32 from 40, which gives me my new number, which is 8. Now comparing 8 to the fourth number on the table being 16. Is 16 smaller or equal? No, it's way bigger. So we're going to put a 0. Nothing changes. Comparing 8 to the fifth number on the table, which is coincidentally also 8. Is 8 smaller or equal than 8? Yep, it's equal. So we're going to put a 1 there. And since we've got a 1, we're going to subtract 8 from 8, which gives me my new number being 0. And like I said at the first number, which was 192, as soon as you hit 0, you know everything else on the table will be 0. So comparing that little 0 vase to the third last number there on the table, is 4 smaller or equal? No, it's not. It's bigger, so we're going to make a 0. Number 2, is it smaller or equal? No, it's not. And the last one, number 1, even that is bigger, so we're going to make a 0. So there we go, guys. Completely converted to its binary form. Just like before, I'm going to put that at the bottom left there for you guys. So we've converted 2 octets successfully now. Alright, and like before, I'm going to clear this table again. So there we go, nice and clean. So we've got the 2 little octets that's been converted at the bottom. What's the next number? That's going to be 15, guys. So maybe you're going to start seeing a pattern here. Obviously, the first 4 numbers in that table are all bigger than 15. So I can already tell you, the first 4 numbers are going to be zeros. Because we're only going to make a 1 if that number in the table is smaller or equal. And I can see up to number 16, they're all bigger than 15. So I can already tell you the first 4 is going to be 0. And we're only going to start getting 1s maybe from the number 8 on the table. But let's go through it. So we've got 15 there at the bottom left. There's our magic number. Looking at 128, is it smaller or equal? No. So we're going to put a 0. 64, is it smaller or equal? No. We're going to put a 0. 32, smaller or equal? No. We're going to put a 0. 16, smaller or equal? No, it's still bigger, so we're going to put a 0. And now we're getting to the good stuff. The fourth last number on the table is 8, smaller or equal than 15. Yes, finally, we're going to make a 1 there. And when we have a 1, what happens, guys? We're going to subtract that 8 from the 15. My new number is 7. Now, comparing that 7 to the next number on the table, being number 4, is 4 smaller or equal than 7? Yes, it is. It's smaller. So we're going to put a 1. So we subtract 4 from number 7. That gives me number 3 now. Comparing my number 3 to number 2 on the table, is number 2 smaller or equal than 3? Yes, it is. It's smaller. So we're going to put a 1. We subtract 2 then from number 3. My new number is 1. And looking at the last one on the table, is 1 smaller or equal than 1? Yes, it is. It's equal. So we're going to put a 1 there. And there we go, guys. Once again, we have converted that 15 to its binary form now, which is coincidentally 4 zeros followed by 4 ones. I did not plan for that. It just turns out like that. And I'm going to put it there at the bottom. So there we go. At the bottom, we've got 3 octets at the bottom left now converted. So I'm going to clear this table again for the last time. At least when it comes to converting from decimal to binary, it'll be for the last time. And I'm going to once again use a different color. So our new number being the last one in that IP address, which is 7. I'm going to put that at the bottom left for you guys. So once again, same pattern, guys. I can already tell you the first 5, not the first 4, but the first 5 numbers on this table is going to be zeros. I can tell you because they're all bigger. Even the number 8 on the table is bigger than 7. So they're all going to be zeros. But let's go through it nonetheless. I'm just going to go through them quicker. So starting with 128. Is that smaller or equal than 7? No. It's much bigger. So it's a 0. 64, bigger. So it's 0. Looking at 32 on the table, it is bigger than 7, so it's a 0. 16 is bigger than 7, so that's a 0. Number 8 as well. Even it is bigger than 7, so it is a 0. Now we're getting to the part where it might possibly be 1s. So comparing our number 7 to the bottom left with number 4 on the table, is 4 bigger, smaller, or equal? So if it's smaller or equal, it's a 1. Yes, it is smaller, so it's a 1. If it's a 1, what happens, guys? We subtract the 4 on the table from the 7 at the bottom left, which gives us our new number, which is 3. Now, comparing our new number 3, with number 2 on the table, is 2 smaller or equal than number 3? Yes, it's smaller. So we're going to subtract that from the number 3. Now, that gives us obviously 1, since we're going to have to subtract number 2 from number 3. So our new number is 1. Is number 1 on the table smaller or equal than number 1? Yes, it's equal. So we're going to make a number 1. And there's the last octet converted to binary. I'm going to put it here at the bottom left for you guys. Well, now it's more towards the bottom right, but you get the idea. So it's there at the bottom. We have just converted the whole IP address. Well, 1 octet at a time. We had to do it 4 times. We have just converted the whole IP address to its binary form, guys. Now, there's actually a very similar table online you guys are going to see, which basically works to the power of 2. You know, each number on the left. If you look at that table, each number, if you look at the 128, that number is basically the number on the right to the power of 2. So if you look at 64, you know, multiply itself by 2, that is 128. If you look at 64 and you take the number on the right of 64, which is 32, 32 to the power of 2, what is that? It's 64. So basically each number on that table, if you take the number on the right of that number and you basically take it to the power of 2, you'll get the number that you are actually looking at. So there are many other tables out there which involve a heck of a lot more math. They get a heck of a lot more complicated. But the one I've just shown you is probably the simplest and the easiest way to explain this. Alright folks, okay, so I think we've got enough, explained here with regards to converting from decimal to binary. So let's do a quick one from binary to decimal, the exact opposite. So I'm going to clear everything up here. I'm just going to leave those 8 numbers on the table. And at the top right, I'm going to give you guys a binary number, a completely random one, just 10101010, completely and totally random binary number. So using this exact same table, the exact same one as before, we're going to convert it back to decimal. So how this works is you're supposed to take those 8 binary digits, put them into the table, and basically every number that's got a 1 underneath it, that's the only ones we're going to add up. So considering we're only going to add up the ones, I'm only going to add the ones to this table. So if I add the ones to the table, that's more or less where they would be if I look at the number at the top right. So the first one, if I look at the pink number at the top right, the first one is a 1, so that's going to be under 128. The second one would have been a 0, so that would have been under 64, so I'm not even going to add it under 64. The third one would have been under 32, and you get the idea. Basically, every second number is a 1, and that's basically where they would go on the table, is where I added those green ones for you guys. So what we need to do now, guys, is we are going to go and add these decimal numbers on the table, only the ones that's got a 1 underneath it. A 1 is considered on, and a 0 is considered off. Now, you probably would have noticed that that binary number at the top right is actually just 1 octet, because remember, each octet consists of 8 bits, and there's 4 octets. So we actually in reality need to have 52 ones and zeros at the top right. I only gave you guys 1, because I think if you can do 1, then obviously you'll be able to do it, 3 extra more times. So in reality, there would be 32 ones and zeros. You're going to take the first 8 ones and zeros, and you're going to convert it to decimal. And you'll take the next 8, and then the next 8, and then the next 8. You just basically repeat the process until you get the decimal numbers. So if I look at the 128 at the top left there on the table, I'm going to write that at the bottom here, 128. And the next one that's turned on is 32. So 128 plus 32. Which one is next on? So that's going to be plus 8 plus 2. So 128 plus 32 plus 8 plus 2. How much is that? That is 170. There you go, guys. That is decimal. So you just convert it to decimal. So converting from binary to decimal is actually quicker. At least for me, it feels like that. I mean, I stand to be corrected here. You guys can let me know how you feel about this. Let me know in the comments down below which one is quicker for you, and if this method actually works easier for you. But for me personally, converting from binary to decimal is actually quicker, because you literally just go check each octet. You just add the ones underneath each number here, the ones that's turned on. You just add them, and that's very quick. You don't even need a calculator in most cases, but if you really have a calculator, it'll probably go even quicker. Converting from decimal to binary, not that it's slow, but it goes a little bit slower in my opinion. Alright folks, so that is today's lesson. We have just converted decimal to binary, binary to decimal. I hope you guys have learned something. I hope you enjoyed this easy method. If it did, please let me know in the comment section down below. If you learned something, give the video a like, guys. I put a lot of effort into this. You wouldn't believe how long it takes me to draw all this. And if you'd like to know when lesson 6 comes out, maybe consider subscribing. Before you guys disappear on me, like usual, just a shout out to all the guys that sponsor the channel. If you want to become a sponsor, guys, or just support the channel in general, you can find that information in the video description down below. I would appreciate it. So to all the guys that click on the thanks button below the video, if it's available in your country, thank you very much. To those of you buying coffee and milkshakes, thank you very much. Thank you to all the Patreon sponsors. They're on the screen. Thank you to all the guys making PayPal donations. Thank you. They're on the screen. And then, guys, if you don't know, we do have a Discord server. Well, I say we, but it's just me. It's called Free IT Training. The link's in the description down below. It's literally the last link in the video description. If you want to go and join my free IT community, I'm in there. There's other IT trainers in there. People studying this course, amongst many other courses, are in there. Some of them have written the exam. Some of them still need to write the exams. If you want to help someone or if you want to ask questions, maybe someone else can help you. That's the place to be. A community of like-minded people is what I normally say. Right, folks, I hope you've enjoyed this lesson. I will see you in lesson 6 of the CompTIA Network Plus course.